Okay, in this lecture, we're going to be going over how to complete the 2-2-4 worksheet. So I'm going to go ahead and share my screen, or not the worksheet, but the Excel workbook. And so I've got my screen right here, and I'm going to go to 2-2-4. And what it says is, hey, we need the standard deviation, the variance, the range, the skewness, so on and so forth, for all of this. Okay, so what I'm going to do is I'm going to find these values in the game by game tab. Okay, so I've got Baylor field goal, which is H. Then I've got VWX, blocks, steals, points scored. Opponent's field goal percentage. Opponent's blocks, steals, opponent total points scored, which is AP, AQ, and AR. And I'm just going to copy all that just to make life really easy. Whoops, it doesn't like that. There we go. Better. So total points scored, I'm going to reorganize this, Control X, insert cut cells, field goal percentage, blocks, steals. Then we've got opponent's total points scored, Control X, insert cut cells. So now we've got it all in order. So we've got all of this information right here is right over here. So there's a couple of different ways to go about doing this, but the easiest way to do it is to do data, go up at the top, and then click on data analysis. And what we're going to do is do descriptive statistics and press OK. And the input range, what we need to do is highlight all of the data. Okay, and the other thing is we put the labels in the first row. See that we've got the labels in the very first row, so we're putting labels in the first row. And then for the output range, we're going to say, hey, we want this right over here. Okay, and then we want the summary statistics, and that's pretty much it. For the future, I would also encourage you to do the 95% confidence interval as well, but we're not dealing with that as well. We're not dealing with that so much right now. So now it gives us the mean, it gives us the standard error, the median, the mode, gives you the standard deviation, the sample variance. And I think in class I may have said, hey, you can use do this as a population, but because it gives you everything as a sample, just go ahead and use it as a sample. It'll be fine. It's questionable whether or not it's a sample or a population. The question is do you want to use this to infer more information about other seasons? Or if you're just talking about only what's here, then it would be a population. If you're inferring it about other seasons, then it would be a sample. Okay, so we've got the skewness right here. We've got the max, min, sum, count, so on and so forth. Okay, so now this gives us some questions. Standard deviation. Okay, we can literally just come over here and do standard deviation, which is right here. Control C, and then come over here. Oh, looks like I missed one. At the very end, yes, I did. Control C, oops. There we go, Control C. Oh, no, I missed everything. Hold on. So I press Control. I don't know how you would do this on a Mac, but Control, and then I click as I hold down Control. So this works on a PC. Control C. And then I paste. And then I go back over to the variance. Let's see here. It doesn't look, oh, sample variance, there we go. 1, 2, 3, 4. Control C. Okay, and then the range. We've got the range right here. Control C. And then the skew. Okay, no, whoops, I forgot to press Control C. The truth of the matter is that we use the skew a lot of times to say, okay, it's not skewed. But just because it's not skewed does not necessarily mean that it's normally distributed. In order to find out whether or not it's normally distributed, you really need to highlight this and do insert and histogram. And you'll see that this is definitely not normally distributed. What this is extremely positively skewed. And then we can go over, whoops. There we go. That one's also extremely positively skewed. And let's just keep checking, and you guys can check this as well. So even though it doesn't say positively skewed, when we look at the histogram, it really shows us a different story. So even though there is a, there's something that says, hey, it doesn't look that horrible. The fact of the matter is that it's a lot worse, and none of this is really normally distributed at all. Let's see here. Is any of this normally distributed? Nope. And I feel like there's something going on that's wrong here. Well, I guess none of it is really normally distributed at all, but we're going to pretend that it is. And so when we pretend that it is normally distributed, we're going to try to do all this. However, what we know is because it's all the data is not normally distributed, we know that we can't really trust what the information that we're getting from it. So the next question is 68% of the data falls between what two values? And you can spread this out a little bit, and it probably should be like this more. And then do high and then low. Okay, so 68% of the data falls between what two values? And so what you can do here is you can do the mean. And why don't we do this? We'll Control X and go down one more. So we'll do mean. And I'll go and get the mean. So the mean is right here. Control C, Control V, okay. And 68% falls between what two values? And this is going to be, if you look at this fun little worksheet that we have, let's see here, file, open, 1-. You can use this worksheet right here to help you to know, hey, 68% is within one standard deviation above and below. Okay, so what we have to do is add one standard deviation. So we'll do equals the mean plus one standard deviation. Then we can also do equals the mean minus one standard deviation. Okay, then this right here, 47.5% falls between the mean and what value below the mean. Okay, so between the mean and what value below the mean. So we find the mean, and it's at 48.5 is what I think it said. Yeah, 47.5, 47.5. And so if you look at this, 47.5, that's going to be 34. And then what's 34 plus 13.5, that's going to be 47.5. So it's two standard deviations below the mean. So what we're going to do right here is we're going to do equals the mean minus 2 multiplied by the standard deviation. Okay, so there's that value right there. So between this value and the mean, 47.5% falls between those two values. And 99.7% of the data falls between what two values? Once again, coming down here, you'll see 99.7 of the data falls between 3 standard deviations plus or minus the mean. So right here, we'll do the upper value. So 3 standard deviations, so equals the mean plus 3 multiplied by the standard deviation, then equals the mean minus 3 multiplied by standard deviation. Okay, And then 13.5% of the data falls between 1 standard deviation and 2 standard deviations above the mean. Okay, so we've got 13.5 between 1 standard deviation and 2 standard deviations. So between this and this right here. Okay, so what we're going to do is equals mean plus 1 standard deviation for the lower, then equals mean plus 2 multiplied by the standard deviation. So 13.5% falls between this, and then 0.3 falls beyond these two values. So 99.7 falls between what two values? So that means that 0.3 falls beyond these two values. So what we're going to do is it's literally the exact same thing, 99.7 within, 0.3 beyond. So we're just going to go like that. And then I'm going to copy the formula again. And there you go. Now, if you wanted to, you could do this over and over again all the way down, or you could also just highlight these and drag the formulas, and it will give you all the answers. The other thing that you can practice doing, which I'd highly encourage, is actually using the Excel formulas. So equals average, okay? So this is the Excel formula, average. Then this right here would be standard equals standard deviation for the sample. Once again, I would probably consider this a population, but you could do standard deviation for a sample because that's what this would give you. Same thing for equals variance for the sample. And then range would be equals max of the range minus min of the range. Okay. And then skew, you would literally just do equals skew. Okay. And then put the range inside of there as well. And so just to show you what this would actually look like, I would do equals skew, then I'd go to game by game and go to Baylor's score. So here, let's go to Baylor's score. And I'd highlight all this and press enter. Okay. And you'll notice right here and right here, the exact same values, right? And then down here, you just do everything again. So that's how you would do all this. And I would encourage you, get used to doing these. But then also, if you want some practice with the data analysis tool, it's there for you as well. In short, from what I can see, just off of all this information, I really wouldn't trust this data too much. I wouldn't trust any insight that we get from this, even though it says that it's not very skewed. It looks very skewed. And so I would want to, just because the skew gives you one indicator, doesn't mean that it's completely correct. I would very much so try to look at a little bit more information to see, can we trust this data before you really grab insight from it. So that's how you do that, and just keep practicing at this so that way when you are doing your work, quizzes and exams, you'll be able to do it really fast. So, and that's all we got.